Okay, so make sure your calculator's in degrees. You plug it back into your calculator, sine of 105. I'm using my 84 because I can't find my Inspire, but it's around here somewhere. I will find it in a minute. So I get 0.9659, rounding to 0.966. Which technically means I should have little wavy lines right here, but they put the equal sign, so I'll put them. Technically they should be, because I rounded it. Okay, so now I'm going to do sine of 45 plus sine of 60. And that gives me approximately 1.573. So the question was, if I add 45 and 60 together, I get 105, which we know we can do. That's where sine of 105 comes from. But if I distribute sine, I get sine 45 plus sine 60. So I put that in my calculator and I got 1.573. So they're not the same. So the question is, what conclusion can we reach? Well, the conclusion I reach is distributive property does not work for trig functions. You cannot use distributive property. Instead, we have to use a formula. They give it to you right down here. It says use the formula sine of a plus b equals sine a cosine b plus cosine a sine b in order to find the value of sine 45 plus 60. Okay, so this is just going to be plugging numbers into a formula. So you can say, we'll say that the 45 is our A value and the 60 is our B value. So I'm going to write sine 45 cosine 60 plus cosine 45 sine 60. So far so good? Now, the point in this particular thing would be for exact answers. Because clearly, if I just need 45 and 60, I can just put sine of 105 in my calculator. But we want to actually use it to get exact values. 45 and 60 are both on my unit circle. Now, we got really good there for a while of using our unit circle in radians. But now we've got to use our unit circle for just a few minutes in degrees. So I can left-hand trick this. Which one of these is a 45-degree angle? Middle, right? So sine is square root of 2 over 2 and cosine is square root of 2 over 2. So I can replace sine with square root of 2 over 2. I haven't done 60 yet, so I'm going to leave a blank there. But I just did cosine at the same time. Since I find both cosine and sine at the same time, I'm just going to skip over and fill in cosine. Alright, so now I'm going to sine 60. Which one's 60? So my cosine value is a half. My sine value is square root of 3 over 2. So cosine is a half, and sine is square root of 3 over 2. Now, please excuse my dear Aunt Sally. I have to multiply the things inside of these parentheses here. When you multiply fractions, you multiply straight across the top and straight across the bottom. So I get square root of 2 over 4 plus square root of 6 over 4. Now, I have a common denominator, so I could add these things. So the denominator, the common denominator, just carries across. You can add across the top, but don't forget radicals. You cannot add radicals unless they're the same. So really, the only thing I can do is just write them down. Square root of 2 plus square root of 6. Because they're not like terms. Radicals behave just like variables. Like terms can be added. If they're not like terms, for example, x plus x is 2x. X plus y is just x plus y, because you can't but you can multiply them. So we'll get to a multiplication one in a minute. Okay, so now what I'm going to do is just check and see if this gives me the same value that I got at the top of the page. So I'm going to plug in my calculator. Square root of 2 plus the square root of 6 over 4. And I got 0.9659, which is 0.966, which is exactly what I got at the top. Okay, so here are the identities. It works for sums and differences. So just look real quick. Sum identity, sine of A plus B, those are any two angles, equals sine A cosine B plus cosine A sine B. If you've got subtraction, it's the exact same thing, it's just a subtraction in the center. Alright, so now now the whole point in all of this. This says, for me to find the exact value, not a decimal approximation, but an exact value. Exact values have to come off of the unit circle. So it says find the exact value of a 15-degree angle. Now, is a 15-degree angle on the unit circle? No. So I'm going to have to use the things I know from the unit circle. So let's just talk quadrant 1 for a minute, since 15 is less than 90. What angles are on the unit circle in quadrant 1? 30, 45, and 60. Is there any combination of those angles that would give me 15?
Well, half of 30 is
45 minus 30. 45 minus 30 gives me 15. And what I'm looking for is this, right? I'm looking for sine of 15. Well, that's the same thing as sine of 45 minus 30. And now I can use this difference identity. So I'm going to do sine of 45 cosine of 30. This is a subtraction problem, so I'm doing minus cosine of 45 sine of 30. And I'm going to pull those values off the unit circle. Now we just did 45, so that one's easy. Square root of 2 over 2 for both sine and cosine. But 30, which finger is that? This one. So my sine value, or let's do cosine first because it's on top. My cosine value is square root of 3 over 2. My sine value is a half. Multiply. In this case it's subtraction, but I do have a common denominator. You can't subtract radicals that aren't alike either, so you just write them down. And that's all it asked for was the exact answer. So you do not have to plug it in your calculator this time to get a decimal approximation. Because that is your exact answer. Alright, so now, we're going to do the exact same thing on this one. The only difference is now they've got a bigger angle, 285. So I'm going to have to go past quadrant 1 and go into quadrant 2. So if I go 90, what is the next angle in degrees on my unit circle? 120. And then what's the next one? Real quick. Okay, if this is 30, and this is 45, and this is 60, then they have, this one mirrors this one, it's 30 degrees away from 180. So what would that be?
150.
150. This one is 45 degrees from 180. And this one is 60 degrees away from 180. They also match up their ordered pairs. Okay, so now, there's more than one way to skin a cat here. Because I could also do 270 plus 15, because we just found 15. Or you could do, I could do one of these over here minus one of these from here. You can do it whichever way you want, it doesn't matter. Whatever way you see it. But for the purposes of us all doing this one the same, let's use things from quadrant 2. And I need them to total 285. So what am I going to use? 150 and 135. So you're going to do sine of 150 plus 135, that equals 285. Plug it in and you do real quick. I have to call my advisor real fast. And y'all, you do, and then we'll see if we get the same answer. Hi Jean, this is Kelly Bogan. I'm good, how are you? Graduate certificate. Okay. Yes. I think so. I've been going to Angelo State, and I think it's very similar. Okay. Is there anything in summer 2, or they're both just in summer 1? Okay. So that by summer 2, I won't have anything. Oh. Awesome. Okay. That's all I need. Yes. Okay. 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 Awesome. Yes. Makes it easy. Yeah. Yeah. Okay.
That's okay. Are they black profiles with a circle? Yeah. Yep. Because when we were at the baseball game in
Okay. All right. Okay. Right. Exactly. Yeah. No, that's it. So when I go into register now, the hold, since I've now talked to you, the hold will be off and I'll be able to register. Awesome.
You were? Wait.
Okay. Okay, great. Thank you very much. I appreciate it. Okay, thank you. You have to put negative because it's in quadrant 2. So, sign. By the way, it doesn't matter what you put, which one you put first. So, if you and your neighbor might put, like I put 150 first, but you might put 135 first. It doesn't matter because this is addition, and addition can be done in any order. So, if I do that, I got sign 150 plus sign 135 plus sign 150. Sign 135. The 35s are easy because that's square root of 2 over 2, but cosine is negative in quadrant 2. So don't forget that. You got to make that one negative. And then 150 lines up with 30. So if I'm left-hand tricking this, I use this one. So cosine is square root of 3 over 2. It has to be negative, and sine is a half. So I end up negative square root of 2 over 4 plus negative square root of 6 over 4. So your final answer ends up negative square root of 2 minus negative square root of, or minus square root of 6 over 4. Or if you wrote negative square root of 6 minus square root of 2 over 4. Either way, it's the same thing. Are we okay? Not bad? Any questions? All right. So down the top of the page, we're doing the same thing. So they want us to simplify each expression. So sine of x, cosine of 2 pi over 3. Now, when I go to actually plug values in, I can't do anything about sine of x because x is an unknown value. So it just has to remain sine of x. But cosine of 2 pi over 3, we actually just did, because 2 pi over 3, well, we did it a minute ago. 2 pi over 3 is a 60-degree angle. It's this one. So it's going to have the same values as the 60. This one. Except for it's in quadrant 2. So cosine is going to be negative half. Plus, my sine value is square root of 3 over 2, and cosine I can't do anything about because it has an x in it. Is everybody okay? Now, we're just going to simplify simplify this, make it look a little nicer. So sine is over 1 and cosine is over 1. So let's make those fractions. So I'm gonna come up here. I'm gonna make it negative sine x all over 2 plus square root of 3 cosine x all over 2. And since they have a common denominator, we'll just write it all as one big term. Negative sine x plus square root of 3 cosine x all over 2. Everybody sort of kind of okay?
Okay, I'm confused on this.
Where'd you get confused?
Whenever you're doing the cosine of 2 pi over 3, I thought cosine was on the bottom.
Cosine's on the top. Remember, it's x and y. Cosine, it's alphabetical order. X then y, cosine then sine, top then bottom. We read from left to right and top to bottom. So cosine's always on top. Okay, so we're going to do it again. Sine of pi over 2 cosine theta minus cosine pi over 2 sine theta. Pi over 2, where is that? Straight up. So what's the ordered pair straight up? 0, 1. So sine is 1. 1 cosine theta minus 0 sine theta. So this cancels out. 1 times cosine is just cosine theta. So that really did simplify things. Alright, so now on C, we're actually going backwards because 75 and 15 aren't on the unit circle. But 75 plus 15 is 90. So because it's written like this, I know that that's sine of 75 plus 15, which is really just sine of 90. And what is sine of 90? 1. Sine is your y value. Sine's the y value. Okay, now same thing here, except it's subtraction. So I'm doing 290 minus 50. Alright, so now I gotta figure out where 240 is on the unit circle. I know this, that, what is that? 270. So 240 backs up 30 degrees. So now, if that's the case, because I'm used to radians, I would have 3 of them. Everybody with me? Like if I backed up, there's also another one here, and all together there's 3 of those on bottom. Yes, are y'all with me? So that means it's got a 3 on bottom. So that means... Okay. No. If 270 is straight down, then 230 is about right here. I backed up. Or 240 is about right here. I backed up 30 degrees, which means I'd back up 30 degrees right here. And there's 3 pieces. There's 1, 2, 3. I've just broken pi into a third. So that's what helps me know what finger to use. So that means I'm using this finger. And my ordered pair is cosine is a half, sine is square root of 3 over 2. And that's the one I'm concerned about. Now the only thing other thing I have to concern myself about is what quadrant I'm in. I'm in quadrant 3, and everything is negative. Everybody okay? So okay? Alright, same process for the next couple problems, but now we're on the cosine identity. Now notice the difference. Cosine groups cosines. Cosine, cosine, sine, sine. That's how you're going to know that you're doing a cosine function and not a sine function. But here's the big difference. When it's plus inside of the parentheses, it's minus in the identity. So cosine has opposite signs here. Okay, so don't forget that part. But the process is the same. Before we actually do one, they want us to plug it in our calculator to see if we're going to get the same answer. So you got to be in radians again. Back to radians. I got negative 0.5. So I don't even have to write wavy lines because it's just negative 0.5, so I'm not approximating. That's an actual result. So now let's do it by hand using the identity that they gave us. This is a sum identity, so I'm using the top one. So I have pi over 6 plus pi over 2. So I group my cosines together. Yes, ma'am. Yes, ma'am. Oh, Miss Fellows. She has a call me to read class period. Okay, so pi over 6, that's this finger. So cosine is the square root of 3 over 2. And then cosine of pi over 2. Pi over 2, remember, is straight up. So cosine is 0. Sine of pi over 6 is a negative half. Sine of pi over 2 is 1. So that gives me, oh, that cancels out, and it leaves me with negative a half. Which means they're exactly the same. I got 0.5 when I plugged it in my calculator. I got negative half when I did it on the unit circle. Everybody good? Alright, so now back to degrees on your calculator. This one is a decimal approximation. Rounding to 3 decimal places, I got 0.259. Okay, so I'm plugging in. Now remember, it's with cosine, you group your cosines. Cosines go with cosine, sine go with sine. And the sign is opposite. So this is a subtraction, which means inside of the identity it's going to be plus. Alright, so cosine is 120. That's the same thing as 2 pi over 3. So I'm using, again, we've already done this one a couple times, but there's my 2 pi over 3. I'm going to go ahead and plug in both things. So cosine of 120 is a half, but it's in quadrant 2. Cosine is negative there. I'm going to do my sine value at the same time since I already have it on my hand. Square root of 3 over 2. Sine is positive in quadrant 2. And then we already know 45. That was an easy one. So I get negative square root of 2 over 4 plus square root of 6 over 4. They have a common denominator, so you can go ahead and add them. And I'm just going to plug that into my calculator and see if I get the same thing. That's it for today because everybody else, we only got to that. So we'll do tangent sum and difference